Example 3. An experiment consists of tossing 3 fair, not weighted, coins, except that one of the 3 coins has a head on both sides. Describe the sample space and compute the probability of obtaining the indicated results. Okay, so what we're going to first do is we are going to try to draw out our sample space. Remember all possible outcomes, okay? So what you're going to do is you're basically tossing 3 fair coins, okay? The only difference is, okay, so if you've got 1 coin, one side is heads, the other side is tails. The second coin, one side is heads, the other side is tails. And then on the third coin, both sides are heads. Okay, so that's something you've got to keep in mind here. Okay, so let's say that you had 3 coins. Let's say you could tell the difference between the 3 coins. So maybe this was a penny, this is a dime, and then this one's a nickel, but the nickel's all weirded out because it's got 2 heads on it. Okay, so there's some way of being able to tell the difference between the 3 coins. Okay, so imagine you have the penny, the dime, and the nickel in your hand, and you shake them up, mix them up, and then you throw them, and you see how these coins land. Okay, does each one land on heads or tails? Okay, so we are going to try to draw out what happens. Okay, so imagine, like I said, you can tell the difference between the coins. So you're going to be able to say, hey, this coin landed on this. Okay, all right, so let's talk about, all right, so you throw your coins in your hand, okay, and let's say what's going to happen with the penny. Well, the penny has heads or tails. Okay, so there's 2 options for the penny. Okay, it's either going to land on heads or tails. Okay, so then we need to look at what happens with the dime. Okay, so you go and check out the dime. How did it land? Well, the dime is 2-sided as well. Okay, so the dime has a couple of possibilities. Okay, it can either land or on heads or tails. Okay, so what I'm doing here is I'm making a tree diagram. Okay, we've looked at one of those before. Okay, so remember, if the penny landed on heads, okay, that has no impact on what happens with the dime. Okay, so it's possible, even if the penny landed on heads, it's possible for the dime to still land on either heads or tails. Okay, if the penny had instead landed on tails, okay, again, that would not impact the outcome of the dime. Okay, if the penny landed on tails, it's still possible that the dime landed on either heads or tails. Okay, so remember, this is creating different possibilities. Okay, so we haven't taken the nickel into account yet, but so far you've got 4 options here: the penny landing on heads, the dime landing on heads, the penny landing on heads, and the dime landing on tails, and then the penny landing on tails and the dime landing on heads, and then finally the penny landing on tails and the dime landing on tails. Okay, we're going to create the last bunch of possibilities by incorporating the nickel. Okay, the nickel is the weird coin. Okay, it has heads on both sides. Okay, so no matter what, okay, it's always going to turn up heads. Okay, so if the penny had landed on heads and the dime had landed on heads, the nickel is going to land on heads. Okay, that's going to create, if you follow this little path, it's going to create the outcome that all 3 coins land on heads. Okay, all right, so then we have to keep going. We keep drawing branches. Okay, so the next possibility was that the penny landed on heads, the dime landed on tails, but of course the nickel has to land on heads. Okay, so that's going to create your next possibility. Okay, so if we did this way, follow that branch. Okay, heads, tails, heads is another possibility. Okay, all right, so next, if the penny had landed on tails and the dime on heads, okay, the nickel is still landing on heads. Okay, so this following this path creates this possibility. Okay, so penny lands on tails, dime lands on heads, nickel lands on heads. Okay, so that's that possibility. Okay, one more outcome here. So lastly, if the penny landed on tails, the dime also on tails, but the nickel always lands on heads. Okay, so if you follow that last path, this is going to be penny on tails, dime on tails, nickel on heads. Okay, so that's going to be this particular path. Okay, so these are your outcomes, okay, that come from doing this little experiment. Okay, so if you're trying to describe the sample space, okay, these are the particular outcomes you get. Okay, so heads, 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 tail, heads, tails, heads, heads, and then tails, tails, heads. Okay. And for each of these, remember, the first letter is referring to the first coin or the penny. The middle letter is referring to the outcome on the second coin or the dime. And the third letter is referring to the outcome on the third coin or the nickel. All right, so now that we have the sample space, we can go below and try to answer some of these probability questions, okay? All right, so let's scroll down, okay, so see our first question. Okay, so we want to know what is the probability of two heads turning up, okay? Well, first of all, remember, each of these scenarios was an equally likely outcome, so we can apply our basic probability principle here, okay? So we are going to, form our fraction. In the bottom, we're going to write down the total number of possible outcomes, okay? So if you count in our sample space, we have 1, 2, 3, 4 possible outcomes, okay? And then what we have to do is go to the numerator, and to compute the numerator, we have to figure out of the sample space, how many of these meet our criteria, okay? How many of these guys have exactly 2 heads, okay? Well, this one doesn't count because it has 3 heads, okay? This guy, you see 2 heads present, okay? This guy, you see 2 heads present, okay? This guy, you see only 1 head turning up, okay? So 2 out of the 4 outcomes have 2 heads, okay? So the probability of this happening, of 2 heads turning up, is 2 over 4, which is 1/2, which is 0.5, okay? So half the time. All right, so let's keep going. All right, next, okay, in part B, we want the probability of 0 heads turning up, okay? Again, equally likely outcomes. Okay, so do our basic probability principle. There's 4 total outcomes. For the numerator, we need to go look at the outcomes and figure out which one or which ones meet our criteria. Okay, so we're looking this time for 0 heads. Okay, so when you look at this, every single one of these outcomes has heads in it, because remember, the nickel, the third coin, it had heads on both sides, okay? So that's why each of these outcomes is going to contain a head, okay? So 0 of the outcomes meet our criteria, okay? So 0 out of 4, that's our probability. 0 divided by 4 is 0, okay? So this event cannot happen, and that makes sense because of that 2-sided coin with heads, okay? All right, last one, okay? What's the probability of more than 1 tail turning up, okay? Again, our denominator is going to be 4, okay? So now we've got to go figure out how many of the outcomes meet this criteria, okay? More than 1 tail, okay? So this means 2 tails, 3 tails, or 4 tails, okay? We know that, wait a minute, I'm losing my mind. Okay, we can't have 4 tails because remember, we have 3 coins. Okay, so there's no way to have 4 tails. Okay, all right, so when it says more than 1 tail, we're either looking for 2 tails in our outcome, or we're looking for all 3 being tails. Okay, all right, so let's go look for this. Let's go to our sample space. Okay, here I don't see any tails, so that doesn't work. Here, this only has 1 tail. okay? This guy, one tail, okay, so that doesn't work because it's not more than one tail, okay? This guy fits the criteria, okay? There's two tails there, okay? So 1 out of 4 meet that criteria. So the probability is 1 out of 4, okay, which is 0.25, okay? All right, and that is how you do this problem.